Hello viewers, in today's session we are going to discuss another important problem from derivatives in which we are going to find out the derivative of this function f of x is equal to sine of sine x using first principle, right? So let us start. Now see, we have already discussed a lot of problems related to finding out the derivatives of functions from first principle. So to use this first principle, we start with the definition of derivative of a function. Now see, if we have a function, say y is equal to f of x, then the derivative of y with respect to x, which is f prime of x, is given by this limit, that is limit h tends to 0, f of x plus h minus f of x divided by h, right? And here h is a very small quantity, which is infinitesimally very small, right? So we'll start with this limit to get the derivative of sine of sine x. So now we have a limit h tends to 0, f of x plus h can be obtained by replacing this x by x plus h. So we have sine of x plus h, and then we have f of x, which is sine of sine x, and here we have h. Now to simplify the numerator, we can make use of an important identity from trigonometry, right? So if we take a is equal to sine of x plus h and b as sine of x. So let us take this sine x as b and sine x plus h as a. So now we have this identity, that is sine A minus sine B is equal to 2 times cos A plus B over 2, and sine A minus B over 2. So we'll apply this identity to simplify the numerator. So we have limit h tends to 0, and here a sine of sine x plus h. Sine x plus h is a, so we have sine a minus sine b, because sine x is b, and here we have h. So now we can write limit h tends to 0, and we have 2 times cos a plus b over 2 and sine a minus b over 2 divided by h. So here we can write h. So now we have limit h tends to 0, 2 by h, and we have cos, and for a we can write sine x plus h plus b is sine x and divided by 2, and then we have sine, and a is the sine x plus h minus sine of x, b is sine of x divided by 2, right? So now we have to evaluate this limit. Now to evaluate this limit, what we will do, we can write a limit h tends to 0, and we'll first write this expression. So we have cos of sine x plus h plus sine x divided by 2, and then we can take this expression, that is 2 over h over here. So we can now write limit h tends to 0, and we have 2 over h and sine, and here we have sine x plus h minus sine x over 2, right? So now we have the product of two limits. So let us call this limit as L1 and this limit as L2. So now let us separately find out L1 and L2. So L1 is given by this limit. Now here we have limit h tends to 0. So let us take h is equal to 0 over here. So we have cos and then we have sine x plus 0. Then we have here sine x divided by 2. So we can now simplify it. Cos, we have sine x plus 0 is sine x. So we have sine x plus sine x, that is 2 sine x divided by 2. So now we can cancel 2 and 2. So we are left with the cos of sine x. So the value of the limit L1 is given by cosine sine x. So now let us find out the value of the limit L2. So we have limit h tends to 0, 2 over h sine x plus h minus sine x over 2. Now to simplify this term, we'll again make use of this identity, taking a as x plus h and b as x. So we have limit h tends to 0, we have 2 over h sine, and we can now write 2 times cos a plus b over 2. So we have x plus h plus x over 2, and then we have sine x plus h minus x over 2, and this 2 is given by here, right? So now this 2 and this 2 get cancelled. We have limit h tends to 0, 2 over h sine, and here we have x plus x 2x. So we have 2x plus h over 2, which can be written as x plus h over 2. So here we have cos x plus h over 2, and then we have sine x and x get cancelled, so we have sine h over 2, right? So now to simplify this limit, what we will do, we'll write limit h tends to 0, 2 over h. Then we have sine of uh, cos x plus h over 2 and sine h over 2. So we'll multiply the numerator and denominator by this term, right? So we can now write here cos x plus h over 2 sine h over 2, and to cancel out this term we'll multiply here by cos x plus h over 2 and sine h over 2. So in the next step, what we will do, we'll take this term, that is 2 over h over this term, that is here we can write h over 2. So now this limit L2 can be written as the limit h tends to 0. We have sine, then we have cos x plus h over 2 sine h over 2 divided by cos x plus h over 2 and sine h over 2 multiplied with the limit h tends to 0. We have this term, that is cos x plus h over 2 multiplied with the limit h tends to 0, and we have this term, that is sine h over 2 divided by h over 2. So now we have the product of three limits. So now let us evaluate these three limits one by one. Now see, here we have sine of this term over this term, right? That is cos x plus h over 2 sine h over 2. Now see, when h tends to 0, then we have this term also tending to 0, that is cos x plus h over 2 sine h over 2 also tends to 0. So if we take this term as say theta, then when h tends to 0, then theta tends to 0. So this limit is now equal to limit theta tends to 0 sine of theta over theta, where theta is cos x plus h over 2 sine h over 2. So when h tends to 0, then this term, that is sine h over 2, it tends to 0. So this entire term tends to 0. So it implies theta tends to 0. Then we have limit h tends to 0 cos x plus h over 2. So when h tends to 0, we have simply cos x plus 0, right? And then we have limit h tends to 0 sine h over 2 divided by h over 2. So when h tends to 0, then h over 2 also tends to 0. So again we have this form, that is limit theta tends to 0 sine theta over theta, where theta is equal to h over 2. So here the value of this limit is equal to 1, because limit theta tends to 0 sine theta over theta is equal to 1. So now this limit is equal to 1. So we have L2 is equal to 1 times cosine of x times 1. So this is equal to cosine x. So the value of the limit L1 is equal to cos of sine x, and we have just seen that the value of the limit L2 is cos x, right? And now the value of the derivative, that is dy over dx, is equal to the product of these two limits. So L1 is cos of sine x, and L2 is cosine x. So the derivative of this function, that is sine of sine x, is given by the expression, that is cos x times cos of sine x. So this is how by making use of the concept of first principle, we can easily find out the derivatives of functions. Hello viewers, in today's session we are going to discuss another important problem from derivatives, and in this class we are going to find out the derivative of cos inverse x square using the concept of first principle, right? And here we'll see the step by step method how to arrive at the derivative of cos inverse x square. So let us start. So let us take this function cos inverse x square as y. That is, we can assume y is equal to f of x is equal to cos inverse x square, right? And from the definition of first principle, we know that the derivative of a function y with respect to x is given by this limit, that is limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, right? So here we are using the notation delta x for h, right? And here we have the function y is equal to f of x. So the derivative, that is f prime of x, is given by this limit, and this is known as finding out the derivative of this function y using the first principle, right? So when we compute this limit, we get the derivative of y with respect to x, and here delta x is a small increment in x, and the corresponding increment in y is denoted by delta y. So delta x and delta y are the very small increment in the independent variable x, that is delta x, and delta y is the small increment in the dependent variable y. So we have y is equal to f of x is equal to cos inverse x square. So we can now write y is equal to cos inverse x square. So now we can take this cos inverse to the left hand side. So we can now write cos of y is equal to x square. So let us take this expression or this equation as equation number 1. So now let us make a small increment in x, which is delta x, and the corresponding increment in y is delta y. So we can now write cos of y plus delta y is equal to x plus delta x square. So y is now replaced by y plus delta y, and this x is replaced by x plus delta x, right? So now we have these two equations. Now let us subtract equation 1 from 2. So we have 2 minus 1, that is equal to x plus delta x square minus x square, and then we have cos of y plus delta y minus cos of y, right? Now x plus delta x square can be expanded using the identity a plus b square. So we have here x square, then we have delta x square, and then we have 2x delta x, and then we have minus x square. So this is a square plus b square plus 2ab, and here we have the difference of two cosine terms. So here we can make use of an important identity from trigonometry, that is cos of a minus cos of b is equal to minus 2 sine a plus b over 2, and here we have sine a minus b over 2, right? So we can take a as y plus delta y, a is y plus delta y, and b as y. So here we have minus 2 times sine of a plus b over 2. A is y plus delta y plus b is y. Here we have 2, then we have sine y plus delta y minus y, and here we have 2. So now here x square and x square get cancelled. So we have delta x square, then we have 2x delta x, and here we have minus 2 sine, and here we have y plus y is 2y, and here we have delta y over 2, which can be written as y plus delta y over 2. So we have sine y plus delta y over 2, and here we have sine this y and this y get cancelled, so we have delta y over 2, right? So this is our equation number 3. So now the next step is to divide both sides by delta y, right? So here we can write delta y, and here also we can write delta y, right? So what we have done, we are dividing both sides by delta y, and now let us take the limit, that is the limit delta x tends to 0 on both sides. So we have here a limit delta x tends to 0, and here we have limit delta x tends to 0, right? But here what we will do, when delta x tends to 0, then delta y also tends to 0. So it implies that when the increment that is delta x is tending towards 0, then the corresponding increment in y, that is delta y, also tends to 0. So here, instead of writing delta x tends to 0, we can write delta y tends to 0, because when delta x tends to 0, delta y tends to 0. So here we have the term involving delta y. So now let us further simplify both these sides. So we can now write limit delta x tends to 0, and we can take delta x common. So we have delta x plus 2x, and in the denominator we have delta y, and here we have minus this negative sign, and we can now write a limit delta y tends to 0. So first we'll write sine y plus delta y over 2. Then we can write limit delta y tends to 0, and this 2 can be taken in the denominator of delta y, right? So that we have sine of delta y over 2 divided by delta y over 2, right? So that we can convert this limit into the form that is limit theta tends to 0 sine theta over theta. So now we can write limit, and then we have delta x tends to 0, and here we have delta x plus 2x, and see this delta x can be taken to the denominator of delta y, right? So here we have delta y over delta x, and now here we have minus. Now limit delta y tends to 0 sine y plus delta y over 2 is equal to sine of y, because this delta y tends to 0. So this term is 0, and we are left with simply sine y, and the value of this limit is equal to 1, because we know that limit theta tends to 0, sine theta over theta is equal to 1. And remember, when delta y tends to 0, then delta y over 2 also tends to 0. So if we take delta y over 2 is equal to theta, then this limit reduces to limit theta tends to 0 sine theta over theta, and this limit is equal to 1. So here we have 1, so this is minus sine of y. So now we have the limit in the left hand side. So now we can write limit delta x tends to 0, delta x plus 2x, and in the denominator we can write limit delta x tends to 0, and we have delta y over delta x, right? So the distributing this limit notation to the term, that is delta x plus 2x and delta y over delta x, using this theorem, that is limit x tends to a, and we have f of x over g of x, that is equal to limit x tends to a f of x divided by limit x tends to a g of x, and here we have simply minus sine y, right? Now limit delta x tends to 0, delta x plus 2x, so this term goes to 0, so we have 0 plus 2x in the numerator, and this is the notation for dy over dx. So here we can write dy over dx, because from the definition of derivative, we know that dy over dx is equal to limit delta x tends to 0, delta y over delta x. So limit delta x tends to 0, delta y over delta x is given by the notation, that is the derivative dy over dx, and here we have minus sine of y, right? So here we have 2x, and in the denominator dy over dx, and this is minus sine y. So simplifying, we can take dy by dx to this side. So we have 2x minus sine y times dy over dx, and now dy over dx is equal to 2x over minus sine of y. So now this term sin y can be written as square root of 1 minus cos square y, right? Because we know that sine square theta is equal to 1 minus cos square theta, and sine theta is equal to square root of 1 minus cos square theta. So now we have 2x, here we have the negative sign, and here we have square root of 1 minus cos square y, right? Now see, initially we have assumed that y is equal to cos inverse x square. So x square is equal to cos of y. So now taking cos y is equal to x square, over here we have minus 2x divided by square root of 1 minus x square whole square. So this is minus 2x divided by square root of 1 minus x to the 4, right? So viewers, the derivative of y with respect to x is given by minus 2x divided by square root of 1 minus x to the power 4, and y was cos inverse x square. So the derivative of cos inverse x square is given by minus 2x divided by square root of 1 minus x raised to 4. So this is how by making use of the concept of first principle. So first principle means the definition of derivative of a function. So dy by dx is given by this limit, right? And the derivative of cos inverse x square is minus 2x divided by square root of 1 minus x raised to 4. So following the same steps with minor changes, we can easily find out the derivative of sine inverse x square. And this problem is left as an exercise for all our learned viewers.